Hello, everybody. Welcome to Building Energy. We are excited to have on ABB today to talk about electrical room safety, arc flash mitigation techniques, and best practices. Today, we are joined by Danish Bag, and also we are joined by David Seretny. So I'm just going to hand it over to both of you just to do a quick introduction on your roles with ABB, and welcome to Building Energy.
My name is David Seretny. As you mentioned earlier, I'm with ABB Electrification Service for Canada, but my main location is I'm managing the Western Canada division.
Okay, great.
And I've been with ABB for about 5 years now. I work in product marketing for medium voltage indoor apparatus, and that includes some of the things like we will talk about today, the UFIS, basically at the medium voltage level, breakers, medium voltage switches, and medium voltage instrument transformers, sensors. So I handle the marketing side of things.
Jumping right into it then, so obviously with the arc flash mitigation, let's just jump into what is arc flash initially. If you can explain that to the audience, that'd be a great place to start.
So arc flash is essentially a event where there's a release of a large amount of energy due to a fault of the equipment or conductors inside switchgear, for example. So you have a lot of heat generated, a lot of molten metal. There's also a large compression of air as well from the blast, essentially. So that's essentially what an arc flash is.
Okay. So then obviously part of the topic here is mitigation on that. First, what are some of the reasons and some of the events that can happen that cause this? Because it sounds pretty damaging.
The damage can be very extensive, not just to the equipment for the customer, but also for the personnel that might be in the room, for example. You have a lot of, again, like I mentioned, concussive air, pressure, molten metal. If you happen to be walking by the switchgear at that time, there is a chance that you could be injured severely. You could lose your hearing, for example. You could get burns from the arc flash event as well. So it's a very serious event. Nothing you want to have it happen at your facility, and that's for sure.
Going into preventing these arc flash events, is ABB doing like preventative maintenance, or how do you help out your clients in that area?
So with respect to the portfolio at ABB, we kind of tackle and mitigate arc flash events in a couple of different ways. Number one would be through having products and solutions where we, use a physical device, for example, to help mitigate arc flash events. And then the other side would be more on the services side of things, where our certain groups and certain divisions within ABB would look at conducting engineering studies, short circuit coordination studies, arc flash hazard analysis reports at a facility to help tackle the issue of arc flash mitigation kind of holistically from all angles.
Can you get into even more about that mitigation? Like, what are people having to, or like clients having to do to make sure that this doesn't happen as a facility? And does it tend to happen like if you've got older infrastructure, things like that? Can that potentially be an area that's of concern?
So from a field service perspective, our clients usually have us come in and do a maintenance, for example, on a switchgear. So we go inside and take all the covers off. We look at the bus bar. We look at cables to make sure that there's no corona or any faults that are almost happening or on the way to be an issue. So we do that as well as we do preventative maintenance. So we breaker maintenance, cables, switchgear, bus bar, all those things are done as well. So taking that preventative approach to arc flash mitigation is a good way to. Preventative maintenance is the best way to do that as well.
If you're working with these on these projects, how often do you recommend people like bring someone like ABB in to double check that part? I'm actually not aware of. Like I've been around like kind of the like the MCCs and that, but is it pretty regular that people need to be doing the inspection?
A lot of our customers go on a 3 to 5 year rotation, depending obviously on the facility and the production. Yeah. But typically every 3 years is a good timeline to kind of get into the switchgear and make sure that there's no problems. Check your cables, your load cables and such. Just make sure that there's no issues with the stress cones or any other issues. So
yeah, one thing I'd add to that is anytime a customer or a client is making any sort of upgrades to their electrical system, adding in new loads, perhaps adding in new transformers. That kind of, you have to update basically all of the calculations and the analysis that you had performed originally.
Okay.
So, if there is some sort of shutdowns or upgrades that are happening that are going to be part of the, the cycle of the facility itself, then that's when we would then come in to help with that, basically.
Anytime if they're increasing potentially like how much load or like production they need for the electrical, then you might have to be going through that whole circuit.
That's right.
So getting into the equipment side, you touched on it there a little bit as well.
So this was a test that we conducted inside ABB at 50 kiloamps for 100 milliseconds only, right? Between switchgear that has the ultra-fast earthing switch installed and that which doesn't. And basically what it shows you, the amount of destruction that can actually take place inside your switchgear within just a matter of 100 milliseconds, right? So you see here, the primary switching elements are connected to the main bus bar, and that's the bus bars. And what they've done here is they've simulated a three-phase fault between the bus bars. You see that little string, the wire that's connected to all three phases. So this would not be the case in a normative sense. You don't want to have anything there, right? But because this is an arc flash test, internal arc test, you can see that that's how they do it. Now, these are the lens sensors. So this is what will detect the presence of overwhelming light in the compartment. And obviously the current, it's connected to, there's a CT input in the back of the unit as well. And now you'll see actually the internal arc test at 50 kiloamps for 100 milliseconds. And you see on two sides, one is on your left-hand side there, that's switchgear without the UFIS. And on the right-hand side, switchgear with the UFIS, right? So, and the next few seconds will show actually the amount of damage that takes place. So the first is the equipment without the UFIS, right? Switchgear without UFIS, and you'll see
doesn't look good.
The amount of destruction that's basically taken place. You see, there's a lot of carbon buildup from, and this is just in a tenth of a second. Basically, this is the stuff that has happened in a tenth of a second, and for all intents and purposes, this gear is no longer usable. Right? So basically now the customer, whoever has this installed, has to then replace it. And they have to, deal with the lead time, the cost, the installation, the engineering that goes into doing this type of an upgrade, basically. Right?
Right.
And this is custom gear, generally speaking. So you're looking at a year's worth of lead time, right? So, and then this is a test with the UFIS installed.
Okay.
And where this will actuate in less than 4 milliseconds. You see the difference in the damage that's done with the UFIS and without the UFIS that you saw previously.
Yeah.
So you see it's a minimal amount of damage. I mean, you still see some carbon buildup there, but it requires maybe some minor refurbishment. And again, a lot of this depends on how severe the fault is as well.
Right.
This is the worst case that we're simulating here. It's a three-phase fault.
But you can see with the UFIS device, you've actually saved your switchgear.
Yeah, that's what's crazy is the other one's like basically blown apart. Yeah. That other one, it looks like it's going to be usable again.
You can go in there and do a bit of cleaning. Can do a bit of an inspection, switchgear inspection, some testing, and potentially be online. If you have the replacement parts for the UFIS as well, maybe in a week. Whereas the other situation, you might be having some long lead times and your production might be down for a while because of the extensive damage.
And one of the things that kind of gets missed when you're just doing a video of an isolated section compared to a real world situation where you would have a long lineup, right, of this of switchgear is that once this arc propagates, it's not just limited to that section, right? It goes through the whole switchgear. Your whole switchgear gets affected by it. So it's not just one section that you have to replace. You have to potentially replace 2 or 3 sections that are going to be adjacent to that where the arc originates, again, depending on the severity of the arc itself, of the arc event.
Right. Have you seen a lot of advancements from ABB has been around for a long time. Could you kind of get into where the innovations happen, the improvement with technology monitoring? Is that something that's been helpful for this mitigation as well?
Yeah, for sure. So I can touch on that a little bit. There's a couple of ways in the industry where looking from a product solutions perspective, where arc flash mitigation comes in front and center. So one of the ways of mitigating arc flash events are passive. Basically, what we define as a passive arc flash mitigation is any type of method where you're dealing with the consequences of the arc flash event. So not necessarily dealing with the arc flash event as well, but looking after the consequences. So that could include things like having arc resistant switchgear, for example, in your installation. And we have a lineup of arc resistant switchgear. What arc resistant switchgear does is basically anytime an arc event occurs, an internal arc fault occurs inside the switchgear, for example, in a breaker compartment, that equipment is made so that it can handle the immense amount of pressure that is generated and not basically blow out in front of the operator, right? So all of the energy, all of the toxic gases, all of the projectiles, they're basically vented out through a pre-engineered path away from the operator. So whether that be outside of the electrical room or an e-house, for example, or it could be towards the roof.
Oh, they can actually design it so it's actually set up now. So if it does happen, it can go away.
That's right, away. But so the operator in this case, they would still be exposed to some of the heat.
Yeah.
Right, some of the perhaps gases like carbon monoxide that are produced, some of the CO2 that is produced. However, the exposure is limited, right? Some other preventative methods for passive arc flash mitigation include establishing arc flash hazard boundaries, for example. So depending on the voltage levels that an operator is working at, you have to then there's certain approach boundaries that are defined and delineated. Another way of passive arc flash mitigation is, for example, having the right personal protective equipment or PPE on, right? So depending on the different incident energy levels, there's certain clothing that is mandated actually from a standards perspective by the National Fire Protection Agency agency that has like from it goes from when it's the risk is quite low and the energy is quite low. It could just be a cotton t-shirt, whereas when the incident energy is very, very high, could be like a full arc flash suit with a hood, and you basically look like a spaceman when you're operating on the equipment. There's some other you want to add in a few more passive methods.
So a lot of our customers as well, they have means of using, for example, remote racking. So so instead of being in front of the breaker, in front of the breaker cell, you can actually use remote racking to kind of prevent people being too close to the approach boundaries. You're limited in your restricted boundaries. And by giving that opportunity with remote racking, you put people away from the potential for the arc flash event and the hazard. There's also other means of there's a remote racking is a switch as well. There's an ERMS switch. Basically, it modifies the trip settings of the protection relay so that it acts faster if there's an arc flash event. So there's a couple other ways to do it as well from an operations perspective. So those are good examples as well.
Yeah, these would all be passive methods where you're now dealing with basically the aftermath and trying to minimize that as much as possible. And then there's actually active methods of arc flash mitigation that you can employ, which means actually utilizing and designing specifying specific equipment inside that will help you minimize the propagation of that arc event.
Does that get into, like, if you're doing a risk assessment before, what are some of the things that go into that? Like, I would imagine that's a more ideal situation. Obviously, you're preparing for the worst with the hope that you can catch it so this doesn't happen.
Yeah, so a lot of times when we go to customer job sites, there's always discussion around lockout, tagout, remote racking if possible, basically to limit the exposure to the people that are working. So all of that, your PPE. So we talked about earlier about your PPE, whether it's category 1 or 4. Do you have the proper equipment on site to do that type of work?
Yeah.
So that's all kind of a part of the pre-planning. So that's a lot of what we do from a safety perspective in the field. So that's one big step. There's also making sure that the settings for the coordination study is all correct. If you're doing the maintenance, for example, on the breakers and the protection relays, making sure those are current and that their engineered settings are correct for the protection that's needed in case there is an arc flash event. So that's part of a scope as well, usually for maintenance.
So that's a lot of times I would imagine too, if you're going into a new project, you want to have that all developed beforehand, especially with like the latest and greatest in the products that you're providing.
Absolutely.
The one thing I wanted to clarify, because I'm not sure if everybody would know this, when you're saying about you're saying remote racking. Can you just unpack that just a little bit more for myself?
Sure. So for a lot of the older breakers, whether it's ABB equipment or competitors, usually there's an interface where the person, an electrical contractor or the people that work at the facility, need to interface with the breaker, so they'll be right in front of the switchgear.
Okay.
So they may be inserting a racking handle and doing the actual rack out process.
Yeah.
Whereas now there's a few manufacturers that have these devices called remote racking. Essentially, you put it's almost, think about a robot or a piece of equipment on a stand, and it has a motor operator.
Yeah.
Essentially, you move this little device in front of the breaker.
Excellent.
And your people, the people would be standing 20 feet away. And
right.
Your remote racking. So when I say remote, it means the person is removed from being in front of the arc flash potential hazard. So that's what that is.
Yeah, the robotics and the remote is being used a lot in heavy industry now for like the high risk areas. So that's
and ABB has for their switchgear, they have a lot of options as well for the remote racking, which is built actually into the ABB switchgear as well. So it's very forward-looking as well.
Yeah, we have integrated racking motors that are built into the truck itself obviously as an option that comes with the breakers. And what you can do is you can then use the contacts inside the breaker to be able to operate it, connect it to a like a EDMS system or a SCADA system.
Okay.
And so what David was talking about was actually having some sort of a pendant that's 20 feet away, but you could also do it completely electrically away from even anybody being there in the electrical room at all.
I see.
Right. And that's obviously there's a certain cost.
Yeah.
That's going to be that
well, you want to sell it, of course.
Yeah. But you're also thinking from a safety perspective.
Yeah.
It's very important if you're working in front of switchgear that's got high arc flash potential.
Yeah.
The further you can get the people away from that,
what sort of voltage gets into that high risk area that you're dealing with, like for the equipment that you're providing? I'm actually curious on that as well.
So the thing, so I guess conventional, understanding would think that the higher the voltage, the more the danger is, right? But actually, when you look at arc flash incidents and you look at kind of the studies they've done, is that arc flash events happen more frequently with lower voltage levels because people tend to not be as careful. Right. So when it comes to the higher voltage, like medium voltage 4160 or 13.8, people are generally very, very careful about that.
Oh,
right?
okay.
But when it comes to 600 volts, right, people get a little bit, like a little bit.
I'm going to fall into that category.
I think the word we're looking for is complacent.
Complacent.
That makes sense.
Yeah.
That makes sense.
Yeah.
So obviously, the more energy you have, the higher the potential for damages.
Yeah.
But we also have to remember that the lower the voltage is, the higher the current is too. Right. So generally speaking,
right.
you have, but again, 1 amp is enough to kill a person or stop a person's heart. So, any current that you would find in an industrial electrical room can be fatal and have devastating consequences.
That's actually interesting too. So when you lead into like the arc resistant equipment that ABB is providing, it must be really crucial then for the lower voltage, because that's where so many issues are.
Yeah, we have actually ABB MNS MCC and MNS switchgear.
Okay.
You can get it into the arc flash rated switchgear as well. And it basically it's compartmentalized to make sure that if there is an event, like Danish mentioned earlier, with any arc gases, essentially there's a plenum on top of the switchgear, which helps to get the gas.
Sorry, what's on top of
typically it's a plenum.
Okay.
So the plenum actually is essentially a encapsulated vent, which is built, it's added on top of the switchgear.
Okay.
And you can either vent the gas vertically out or out the side of a building, in any house example.
Okay.
And it gets those gases away from the people. So that's
right.
the purpose behind the plenum.
And the way that the switchgear is designed is that the gases are made, if an arc event was to occur, the switchgear is designed that it will then vent it up and away. Right, rather than it venting it to the front of the gear, for example.
Is that fairly new? That seems pretty innovative to be able to do that. Like, or because before things just blowing out.
It is new.
Okay.
And the switchgear is designed very different as well, in the sense that the plates, the covers and doors there's many more bolts that fasten the doors and covers together.
Right.
So yeah, it's relatively new from From a switchgear supply perspective, yeah.
I would say for anybody who's watching this and is in charge of an electrical room,
Yeah.
I would say having arc resistant equipment is probably a no-brainer, right?
Is that part of the regulations yet in Canada here?
It's not. I wouldn't say it's necessarily part of regulations, but I would say it is now starting to become part of normal acceptable practice
Okay.
to have arc resistant switchgear where you're able to have that option available.
So a lot of the utilities that you'd be working with, we won't mention names, of course, but a lot of those ones, would they be when they're putting in these new projects, are they using like the latest and greatest then?
Yeah, so it could be arc resistant switchgear or it could be other arc flash mitigation techniques.
Right.
Again, arc resistant switchgear is one of them, right? Like we mentioned, but there's also other techniques, like for example, arc flash protection release that we can talk about. We could talk about ultra fast earthing switch. So it could be a combination of these technologies working together, or it could be having one or two of them, right? So to try and maximize that operator safety.
Actually, let's get into that switch then. That's a good lead in for that.
So when it comes to active arc flash mitigation, again, there's a number of different techniques that are out there in this industry that folks are employing. First could be arc flash protection relays. And arc flash protection relays basically are designed to take an optical input and a current signal input, right? So anytime you have an arc flash, you have a huge amount of energy that's released and a lot of light is released, right?
Right.
So up to 10 million lux can be released in an arc flash, which could be very damaging to the eyes. But the way that they incorporate that in technologies, they have these lens sensors or these fiber optic sensors, right? Depending on whichever technology that you're using, and that picks up the light signal. Right?
Oh, really? Okay.
And so what the relay will work on, an arc flash protection relay, it will pick up that light and it will sense that there's a lot of current that's taking place. It will then combine that information and send a trip signal up to the breaker. And these are, arc flash protection relays are usually independent relays. They're not usually coordinated with the rest of the protection system, which means that they can act much, much faster than let's say if you were not to have them. Right.
Right.
The other technology that we have at ABB is called the ultra fast earthing switch, and this is I would say a very, very innovative technology in the sense that when you're actually undergoing an arc event, it will basically direct the arc current to ground and collapse the arc voltage, meaning that what would normally take an upstream breaker. If you don't have any arc flash protection relays, could take up to 200, 300 milliseconds to clear. If you have arc flash protection relays, that could be less than 100 milliseconds, basically. And if you employ this ultra fast earthing switch, it extinguishes our arc voltage in less than 4 milliseconds. So the less time you give that arc to propagate, the less destructive energy it has to release. Because if you were to look at the release of energy during an arc event, it's an exponential rise, right? So within 100 milliseconds, for example, you can have cable fires. Within 200-300 milliseconds, you could have your steel and your copper melting, basically. And that's in, a tenth of a second, basically, right?
So you've got this. Now, is this a switch here?
So this is the switch here. So
that's it there. Okay.
Yeah. So you would basically incorporate this between the main bus of your switchgear and your ground. And what it does is basically when that guy senses, this is a quick release unit. Okay. When this senses through light and over current that there is an arc event taking place because of a certain inrush of energy or current, what this will do is it will send this guy, these primary switching elements, a trip signal. There's a little gas that's generated which pushes this moving contact up. Oh, okay. And that creates a path between the main bus and ground, and all of the current is then flowing to.
So it's actually sensing a little bit of the gas, and therefore it.
No. There's a micro gas generator in here.
Okay.
Yeah, that pushes basically. It's kind of like an airbag in your car. Yeah. Right. So similar type of technology. Got it. Where the airbag kind of goes in your face, whereas here it's just pushing this contact up.
So once
and it's very fast.
The pressure that it senses, that's when it realizes it needs
when it
to
senses
engage.
an overcurrent or light,
Okay.
condition, either or, basically, or and.
I don't even understand how that gets invented or how somebody is able to get that all together. But good, that's fantastic.
We've had this guy since the 1990s.
Really?
So it's actually quite old now. So it's like,
that must have saved like hundreds of millions in damage.
Yeah, so we actually have customers who come to us and they say that, hey, this thing, it operated and we can't find, we can't find where the fault is. And then, we would send our service team
Okay.
to investigate, okay, what's going on? How did this thing trip, right?
Yeah.
And then they find out that there's some sort of short circuit that happened. They don't even know where it happened because it works so well, right? So it's after the fact that they find.
Do you have a good case study you'd be able to talk about where they basically employed this as like for risk mitigation?
I have a good example, actually. We did a customer site a few years ago where we installed the protective relay.
Okay.
We also did a bunch of fiber optic install as well.
Oh, okay.
So we essentially went and had a full outage on the customer switchgear, pulled all the breakers out, and then we installed fiber optic cable inside the breaker compartment around the bus bar and any bushings that are exposed. So basically, it was a large install base, but we took the time to do the work and did all the commissioning as well.
Yeah.
And made sure that the fiber optic was installed to protect essentially the entire lineup of switchgear.
Oh, wow.
For one of our utility customers. So yeah.
Is that are you seeing that a lot? Because from what it sounds like, then you can go in, you can take that. You don't necessarily have to replace everything right away. You can just put those mitigation.
Yeah, exactly. Essentially, it's a custom retrofit of the existing switchgear. You're not adding a bunch of parts or components, but you're basically going in and adding the protection relay and a little bit of fiber, and minimizing the cost as well to the customer.
Yeah, for sure.
And what makes this very practical is that you don't just necessarily have to buy brand new switchgear with this thing. You could take this as a kit and basically incorporate it into existing switchgear that might have been purchased in the 1980s. There's no budget to rip it all out and put new one in.
Yeah.
But at the same time, you want to have optimal, operator safety, right?
Yeah, of course.
And basically, with this system, as I mentioned, it will collapse the arc voltage in less than 4 milliseconds. So all of that current is being now directed to ground or left, and then the upstream breaker will then actually trip, isolating that fault in 3 to 5 cycles. So.
You mentioned about putting the fiber around everything. That is for what is that? Is that for sensing everything?
Essentially, yes. So if there's any chance that there might be arc flash incident in a breaker cubicle, in any it could be a lineup of 40 sections of equipment. If it happens in one section, the protection relay will operate and essentially open up the upstream breaker, so it protects that entire lineup. It's not protecting a cell, but it's actually there to protect the entire lineup of equipment. So,
okay.
So it's basically the fiber is a light sensing, and you just kind of route it through all the sections of the switchgear.
Right.
And if there's any light whatsoever, it operates. It provides safety for the operators, and customers.
Oh, okay.
It's a very, good safety device. You're protecting your people, your employees.
Did you go into more of these consequences that you're seeing with the arc flash and kind of unpacking that a bit more as well? Because it's really important so then people listening, obviously, they can
Yeah, sure.
have...
Yeah, I can touch on it. So we provided some photos as well, which kind of show some of the end results of, arc flash events. So you can see there's a breaker which was involved in an arc flash event. Again, you're going to have a lot of molten metal, gases, a lot of heat. There's going to be probably some switchgear damage as well. There's also another photo showing because it's a lineup of switchgear where they were potentially maybe racking out a breaker, and you have some covers on top which were blown off, doors.
Because of the pressure, basically.
Yeah.
Right. And you see the windows are cracked. There's actually a lot of heat that's generated during these events, and when they've actually done observations, they've recorded temperatures as high as 50,000 Kelvin. And to give you a bit of an appreciation of that, the surface temperature of the sun is actually around 5,700 Kelvin. So that's, around 11, 12, maybe 15% of actually the temperatures you would experience in an arc event or potentially experience in an arc event. At the terminals where the arc occurs, they've measured something like 20,000 Kelvin. Right. So it's a tremendous amount of heat that's generated. And you can see from the pictures here that, like the breaker, for example, the terminals are completely melted off.
Mm-hmm.
Right. to give you an idea of the amount of pressure that's generated, right? Not just in the switchgear cubicle, but actually the electrical room. For example, you see the picture of that substation which has actually the roof completely blown off, right?
Is that the third picture with like the brick type building?
Yeah,
Yes,
that's right.
Yeah.
So that was an actual. So that was so much pressure build off, it just blew out the top.
Exactly. Yeah. So and you know when you think about it, I mean that roof would have landed somewhere, right?
Yeah.
So so it's obviously dangerous within the electrical room, but also in the exterior surroundings to the electrical room, it could also be potentially very, very dangerous.
So along with the heat as well, you have a lot of, like I mentioned earlier, a lot of the pressure.
Yeah.
Also pressure on the body. You can lose your hearing. You can, be exposed to flame. So if you're not wearing the proper PPE, you could be exposed to a lot of skin burn.
Yeah.
Very, very high potential for a lot of injury. So it's very dangerous.
Is there continual analysis on like these effects for going forward as you keep developing, like basically like improving the equipment? Like it sounds like it's like pretty phenomenal right now, but are you working with a lot of your clients and like getting data and using that as you continue each year to develop?
I think we are seeing a lot of advancement in the technology, like you mentioned. We spoke earlier about the UFIS and the detection relay. So there's obviously a lot of mitigation that our clients and our customers use to make sure that, number one, they can protect the switchgear, the asset, also protect the people that might be working in the facilities as well. So there's a lot of feedback around what the customers are looking for, and they provide that information to us as well to make sure we can provide the product for them.
Is that set up through as well now? Is there like basically like technology portals or like data portals that you can monitor so you get in all that information now, or how is that, or is it just select groups of clients?
I think a lot of times it's a lot of communication from the customers to maybe our engineering group to kind of share what the information, what they want to see happen, and see if something that ABB can provide. I think there's a lot of feedback back and forth between customer interaction.
With our customers, participate in pilot projects with them to try and develop technology that's going to be in line with their needs and requirements, as well as, a pilot helps us kind of test the waters a little bit before we actually have wide deployment of technology across all industries. So yeah, as a technology company, ABB is very good at doing that.
Well, that's pretty good, gentlemen. We've covered a lot on arc flash mitigation, kind of basically the improvements that are being made, and obviously we'll have all your links so people when they want to get in touch or they want to reach out directly to you. I imagine you said you've got service, you've got the equipment you're actually selling, of course, and then you've got the engineering department. So you've got those three aspects covered for all your clients, depending on their needs. Then.
Yes, we do. So we can provide the retrofit solution.
Yeah.
There's also, from a field service perspective, we can go in and do maintenance as well as do the installation of the retrofit solution as well. And then we have the engineering background as well to support this protection. On
the inputs and outputs, what goes into those engineering studies for, and how does that translate into what you're delivering to the clients?
So for a lot of our customers, they might come to us and say, hey, I need to look at arc flash mitigation, or I need to understand better what are the hazards that I might have in my facility. So they may reach out to ABB and ask us to do a coordination study, arc flash analysis. So we have to essentially, at that point, we engage with the customer and we go to the customer's site, and we have to gather site data. So there might be cable data, transformer data, switchgear data. We have to gather all that information. How old is the equipment? So we have to gather all that information in a package and provide it to our engineering department. And then from there, we kind of reverse engineer get all the data and figure out, okay, so from a supply perspective, what is the potential arc flash hazards that we might see in the customer site, and what's the best way to mitigate it?
Has ABB always done that part of, has that been commonplace to do those studies for a lot of your clients, or is it becoming even more like on the safety side? Is it more crucial that a lot of people are doing this?
I think it's a combination of both.
I think
we're seeing a lot more from a safety perspective with NFPA, CSA requiring that you have labels on switchgear now. So as a manufacturer, we need to provide that component for our new switchgear installation. So you have to have the label which says, arc flash hazard,
right?
How many calories you might, interface with, operating the switchgear or being within your approach boundaries.
Oh, okay.
The potential hazard you might run into. So you're seeing a lot of that more now, not just from ABB, but from other equipment suppliers as well.
Yeah, well, that's a good place to end off. And thank you both for joining. I'm excited for this content that we're putting out with ABB, especially we're doing one here today, and then we're going down to the event tomorrow to do the second one. Thank you both for joining Building Energy. I'm excited because this is the first of 3 episodes that we're doing. Not sure which order they'll come out in, but thank you both. Where can we find both of you if people want to get in touch with you?
So you could find our products and solutions on the ABB website, on the ABB Canada website. I think you can find the link in the description.
We'll put link. Yeah, absolutely.
Or you can contact me on LinkedIn. It's under Mirza Danishbeg if you search me up.
We'll put your link in there as well.
Yeah.
Same with yours, so everybody can find you.
Same way for myself.
Okay, fantastic. Well, thank you both. That's for me. I learned a whole bunch more. I mean, I've been around the electrical a little bit, but of course, not an electrician or anything. But that's a great kickoff for this series. And thank you everybody for watching.